Hello and good afternoon, CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this afternoon's video tutorial is going to be on challenge activity number 6, where we're going to take a look at optimizing OSPF. And so if we take a look at our scenario here, you can see that areas have been pre-configured. We need to establish connectivity in the leaf areas and ensure that the non-backbone routers, which are distribution and branch, can communicate with IP addresses in the OSPF domain. We're going to be advertising a default route off of the Internet Gateway, ensure that all OSPF routers can reach the IP 209.165.201.1. It says do not configure any additional static routes or IP addresses. So actually, this one right here, we can knock that out right away. Let's take a look and see on Gateway 1. That's sort of the low-hanging fruit here. We'll go into Global Config, do show run section OSPF. Whoops. All right, so you can see that we're already set up. We're actually doing some redistribution of connected networks and subnets. Remember, that subnets command's critical. We need that in there so that we can redistribute classless connected networks, right? Without that subnets command, we would only be advertising classful subnets. And then we've got our route map named uplinks. Okay, we've got our passive interface on loopback 0, our two network statements. So let's go ahead, let's jump into router OSPF 1. So how do we originate a default route? It's actually super straightforward, very, very easy. Remember, we just say default information originate, right? So default, sorry, I forgot the dash there. Default information originate. Now there's two options we have here. We've got the always option. And then we've got, well, I should say we've got the always option, or we have not using the always option. Keep it in mind that the always option means if for whatever reason that interface, that network that we're using for the default were to for some reason go away, then what would end up happening is the always argument ensures that that network's going to continue to be advertised even if there's no default route, right? Even if we're not going to anything. Okay, and so what I mean by that is, let's say default information originate always, but then if I say do show run section route, we have a default route in here. Actually, do show run include route, or do we have a default route? So they have not defined a default route yet, and so that's what we're going to go ahead and do. So we're saying that even though we don't have do show IP interface brief, even though we don't have a default route defined with an IP route statement, I was making the assumption that they had that in there. They do not. So you can see that 209.165.200.226, if I were to ping, I think the gateway is going to be 209.165.200.227. No, 225. So Control-Shift-6. There we go. So that's our default gateway. So when I say default information originate always, what that means is I don't have to have a statement in here that defines a default route. If I just said default information originate, I would have to have the IP route quad 0 entry, right? The quad 0 entry, and they're pointing to 209.165.200.225. And so we'll put always in there, and again, I thought that they were going to have that in there already. They don't, so we'll just say default information originate always. And that's going to go ahead and take care of our default route. So we'll come back to the scenario here. Oh, do not configure, I should probably read the directions. Do not configure any additional static routes. So that demands that we say default information originate always. So I was getting a little ahead of myself there. All right, so summarize the external networks advertised by branch. We're going to come back to this one up here. The leaf areas, non-backgrounds, just can't communicate with that. We're going to come back to that one. We'll pick off some of the lower hanging fruit here. Summarize the external networks advertised by branch using the smallest possible address block that covers all individual subnets. So let's go ahead and knock that out down here on branch. We've got these external networks. I'm assuming they're going to be the same externals we saw earlier in Discovery 15. Show IP interface brief. And they are. It's these 172, 31, 64, 1, 128. So now we've got to dig in here and see, are these all /20 whats? Okay, so loopback 1 is a 25, a 25, a 24, and a 24. So this is going to be easy, right? Let's go ahead and let's summarize this right now with the smallest possible summary to pick up all the networks. And it might actually be advantageous, although I don't believe we're going to have to. These are all pretty close. So we could probably get this with a single summary to make it the most accurate. So we've got 172, and actually all we need to do is look at the third octet, right? 172.31. Those first 16 bits all match. The 172 8 bits, the 31 8 bits. So we've got 16 bits that match. Then we hit the third octet where we run into an issue, right? We've got 64 in decimal, 64, 65, and 127. So we need to sort this out here in the third octet. So 64 is going to be 0, sorry about that, 0, 1, and then all zeros. 65 is going to be 0, 1, and then all zeros except for the 1 for 64. That's still correct. 65 is going to be 0, 1, 0, 0, 0, 0, 0, 1. And then 127, right, it wouldn't be here, right, because that's 128. So it's going to be 0, and then 64, 32 is 96, and 16 is, what was that, 112, 120, 24, 26, 27. So where do these no longer match up? Right after the 64-bit position, right? So what we're going to have is we've got 16 bits that match, 17, 18. So we know it's going to be 172.31 dot. Are there any bit positions in the on? Are there any bit positions or bit value positions that are in the on position? And yes, it's going to be 64.0/18. Now, we need to make sure that we're doing the most accurate subnet that we can, or the most accurate summary that we can, and that is certainly it. However, if we take a look here, remember that little trick, 2 raised to the number of bits that don't match, 3, 4, 5, 6, 2 to the 6. So 2, 4, 8, 16, 32, so 64 networks is what we're saying. When we advertise that summary right there, we're saying that we are actually representing 64 different networks. However, how many networks are we actually responsible for here? Exactly. We're actually only responsible for 4 networks. So there are 60 networks which this summary is could possibly attract traffic for that we just don't have. And that's where that null zero entry is going to come into play for us. And that's why that null zero entry is important. But again, it's kind of tough to look at this and say that this is the most accurate. I guess most accurate in terms of we've got a single statement. If we wanted to be more accurate, we could do a summary for those 2, and it would be on the button, right? I mean, we could get just those 2 networks. And then we could do a summary for those 2, or we could even maybe fold the 65 in with these and still make it more accurate than what we have in terms of the number of networks that we're saying we represent. And that, excuse me, that /18 is going to be a 255.255. So just 2 bits, 128 and 64 is going to give me 192.0. So again, I guess it would be more accurate. I mean, we'd have 2 summary statements, but I got to think it's going to be less networks than 60 networks that we're actually pretending that we have reachability to. So we'll stick with this single statement. Let me clear this here, 172.30.164. And on the branch router, that is where we are going to do, actually that is where we're going to do the summary. So let's jump in here on the branch router. Remember that those networks are show run section OSPF are being redistributed, right? We are redistributing connected networks now. So let's get into global config. We're going to say router OSPF 1, and I'm simply going to say summary address. Now, why am I saying summary address and not area range here? Exactly. Remember that in OSPF, unlike EIGRP, where we just simply say summary address, EIGRP1, and we throw our summary in there, and we can do that on any interface, anywhere, at any time, for any reason. With OSPF, there's really two spots where you're going to be doing redistribution. You're either going to redistribute at the ABR, the Autonomous System Boundary Router, which by definition means it does not have an interface to external routing information, that it's got an interface in area 0, and then it has one or more interfaces in non-area 0 areas. So that's your area range command, and that's how you summarize at the ABR. Now, how do we address the external routing information? So if you're an ASBR, an Autonomous System Boundary Router, you're going to be doing your redistribution with the summary address command. So I would say summary address 31.64.0, and we said 255.255.192.0. And this is going to result in a summary coming off of the Autonomous System Boundary Router, the ASBR. If I were to say do show IP OSPF, you're probably wondering, how do you know that this is an Autonomous System Boundary Router? And it is right here. It is an Autonomous System Boundary Router. So if you say show IP OSPF, it'll actually tell you on that router what kind of a router it is, if it's an ABR or an ASBR, or if it is both. It also shows us that we're redistributing external routes from connected, right? Includes subnets in redistribution. So that's how we see that information. All right, so it looks like we've taken care of the first two, or I should say 2 and 3. So reduce the OSPF routing table and database in Area 1 as much as possible. Well, when we take a look at Area 1 here, and this should look exactly as it did, yeah, it does. So how could we reduce things here in Area 1? Well, one of the ways to do that is to simply turn Area 1 into a stub. And we could even take it one step further and make it a totally stub, so that the only thing that we're seeing in Area 1 is going to be the default route. So let's see, if I look at the distribution router, I haven't established OSPF everywhere yet, so let's go back into show IP route OSPF, and let's see what we see so far. Yeah, so we don't see anything. Show run section OSPF. So we may now have to address, yeah, we're going to have to address that first configuration section, or should I say first configuration task that's asking for, which is, and actually let's go back up here, and it is to establish connectivity in the leaf areas and ensure that the non-backbone routers dist and branch can communicate with IP addresses in the OSPF domain. All right, so here is what we are going to do. So I'm going to jump onto the HQ router. My guess is that the HQ routers may not have, whoops. So let's see if HQ1 is set up here. So let's say show run section OSPF. All right, so OSPF is enabled. Show IP OSPF neighbors. So I'm neighbors with router 2 and 3. The distribution router, show IP OSPF neighbors. Yeah, so nothing going on here with router 4. So my guess is if we looked at HQ, and HQ has 3 interfaces, no, 2 interfaces. Ethernet 01. So let's take a look on HQ, show run interface Ethernet 01. and that's a 172.16.14.1, and it's a 240, so that is actually set up on the distribution router 16.14.0 area 1. That is also set up. So is show IP interface brief. Why do we not have show IP interface brief? And that interface is up. Let's see if HQ1 is up. I think I'm looking by something pretty simple here. And that interface is also up. So this has me wondering, what am I not seeing here? Why is the neighbor relationship not there? And the area is correct on both. What am I missing here? So I'm missing something right here between distribution and Ethernet 1 that is not making much sense here. Show run, and it's actually up there, section OSPF. And everything is in area 1, so there's no area mismatch. So let's do this. Debug IP OSPF hello. All right, so let's debug the hello. And is MTU... You've got to be kidding me. Okay, so we should have had the adjacency established without any issues, but take a look at what we're seeing in the debug. And this is one of those cases where it's probably right on the interface too, isn't it? If I would have said show run interface Ethernet 01, did I look right by it? It's not there. Maybe it's here. Let's say do you all or you all, and show run interface Ethernet 00, and there it is right there. IP OSPF hello interval has been changed. So they've worked a little T-shoot in here for you to chew on. Again, you see immediately that the hello interval doesn't match. Remember, the MTU parameter needs to match, the hello interval needs to match, the dead interval needs to match, and if they don't, your adjacency is not going to come up, just like we saw right here with the distribution router. And let's see, show run interface. Did they see if they were being super mean here? Yeah, they were. So they set the hello interval to 20 on both Ethernet 00 and Ethernet 01. So there's one of two things we could do. We could go change it on the HQ routers, or we can go into global config here and say interface Ethernet 01, no IP OSPF hello interval 20. We're going to see the adjacency come up, interface Ethernet 01, I'm sorry, 00. And we're going to say no IP OSPF hello interval 20. And now we should see our adjacencies come up, and there they are. Or there's the first one with neighbor 2. So do show IP OSPF neighbors. Yeah, I was definitely not looking for that. There we go. We were in the init. All right, and now we are up. And now when I say do show IP route OSPF, we see the information we're looking for, and we are now seeing right here this OE2, which is our default information originate always, and you can see that that is coming in with a metric of 1. Still the administrative distance is 110. It's an OE2 and a metric of 1 because it is connected, right? Because it's connected. Okay, so we've taken care of the adjacencies. Let's see here in this scenario. All right, establish connectivity to the leaf areas. I think we have done that. All right, and summarize, reduce the OSPF as much as possible. So we're going to stub area 1. That's what we're going to do right here. So make sure that traffic from and to area 1 flows in both directions over the same ABR. And so that's where we're going to get into a little bit of an advanced scenario where we're going to have to tweak the OSPF cost. But first, let's reduce the OSPF routing table here at the ABRs. And so what we're going to do is, we were just on the distribution, so let's take care of this first. We're in area 1. We're going to say router OSPF1 area 1 stub, and then on the HQ routers, in order to ensure that they are both in area 1 totally stub, we're going to go into global config router OSPF1, router OSPF1, and we're going to say area 1 stub no summary, stub no summary, and then we're going to do the same thing on HQ1. So we're going to turn area 1 into a totally stub. So we're going to say router OSPF1 area 1 stub no summary. No summary. There we go. All right. So now when I come down to the distribution router and I say do show IP route OSPF, what is it that I'm going to see? I'm only going to see this single type 3 LSA, right, for the inter area, and it's my default route because we are doing a totally stub. I'm not going to see any type 4s. I'm not going to see any other type 3s other than this type 3. I'm not going to see any type 4s or type 5s because the stub, the regular stub areas, stub and totally stub, do not permit external information. We saw that in the discovery activity 15, I believe. And there are no type 7s because the 7s show up in the NSSA and the NSSA totally stub or the totally stub NSSA, right? Okay, so we've got that taken care of. Now I need to make sure, let me see here if we see show, what am I trying to say here? Do show IP route OSPF. Okay, so we are picking up the OE2 default, and I've got the intra-area information here, but do we have, we're not picking up do show IP OSPF neighbor. So they've worked some troubleshooting in here. All right, so we are two-way druther with 5, which I'm assuming is going to be the branch. So let's make sure that's the case. So do show run section. Oh, it's already up there. Here we go. I had it up there. So yeah, so we are two-way druther, but should we be two-way druther here? Because this is area 2, and this is an Ethernet broadcast multi-access segment. So it should not be druther in both directions. Show OSPF. And do show run interface Ethernet. Let's see if they're throwing, yeah, boy oh boy, they've certainly worked a bit into the challenge activity here in terms of troubleshooting. So you can see here we've got this IP OSPF priority 0 command indicating that there'll be no DR BDR, and let's see, do show run interface Ethernet 02, and is that same? So there you have it. So we are on a broadcast segment, but we're saying that there's no DR or BDR that will be elected, and that is why we are sitting in a two-way state. Now, two-way state is not necessarily always a bad thing, right? But on a broadcast multi-access Ethernet segment, it is, because we should be full and there should be a DR BDR election. So what we're going to need to do is get into interface Ethernet 02, and we're going to say no IP OSPF priority 0. And we're going to go down to the branch router. We're going to say the same thing. No IP, whoops, get into interface Ethernet 00. And there we go. It went from loading to full, but we're going to go ahead and pull it off of here. I don't see any reason not to. IP OSPF priority, or no, sorry about that. No IP OSPF priority 0. So that takes care of that. So we've got our adjacency established, which now means that that summary that we configured here in the do show run section OSPF area or process, we should now be seeing that 172.31.64. So let's come up to the gateway router. It's way up here, and say show IP route OSPF. And are we getting it? Now we see that routing information here. Let's go to the distribution router, right, all the way down here. What are we going to see? Yeah, all we have is a default route down here. So we're not going to actually see that information because this is a totally stub area. And again, Could I change this link here, this area here, into a stub or totally stub? No, I can't. Remember that. I've got external routing information being redistributed in here. All right, so now the final thing that we're going to do is, and these are always sort of the the ones that cause you to think the hardest. So make sure that traffic into and out of Area 1 flows in both directions over the same ABR. So we've got HQ1 and HQ2. We've already turned both of these into totally stub ABRs for Area 1. Now we need to figure out, how do we force traffic to come out of and into the same ABR? Well, we can manipulate the OSPF cost, and there's a couple of ways that we can go about this. So remember that we've got default routes being sent in here, right? Let me get back into the picture. So we have a default route being sent in from both of the ABRs, HQ1 and HQ2, which means I have two exit points out. I can go out HQ1 or out HQ2. What I'm doing right now is equal cost load balancing, where I've got two equal cost paths out, so then I would balance my traffic over those two equal costs. Well, what if I want everything to go out HQ1? So if I come up here to HQ1, what I could say is, I think I'm already in there, router OSPF 1. What I could say is area 1, and if I do a question mark, you can see, set the summary default cost of NSSA stub area. So I could say default cost, and let me lower the default cost down to 3. And let's see what that does. Let me come back down to distribution. And so now what am I seeing? I'm seeing the path out, but what's the path out? It's going up to 172.16.24.2 via Ethernet 0.1. So I lowered the cost, the default cost here, to 3 for area 1, yet the traffic is going this way. So why is that? Let's take the command off. Whoops, sorry. So let's dig into why that is. Because when you set that command, what's happening is I'm going to advertise the route, and actually I'll just read this to make sure it's clear. We're configuring HQ1 as totally stubby. We're advertising the default route with a metric higher than the default value. And so what that does is that will cause, because again, I said default cost of 3. So between the two defaults, the more attractive default is going to be the one out router, or HQ2. Because again, the default metric for the default route is going to have a value of 1 plus the link cost, the outgoing link cost, which is 10, which is why we see 11 in both of those statics, both of those static default routes down here. That's why we were seeing 11. The default cost is 1, and that's why when we looked at, when we were looking at the gateway router, I believe it was one of these, not the gateway, it was HQ1 or 2, looking at the default up to the gateway, do show, where was that at? We saw it as 1, and it's because it was a static, right, or a connected. And we were doing redistribution, I believe. I can't remember where we saw that earlier. But you saw the cost of 1, and that's why the cost shows as 11 down here on the distribution router. Because when we say from HQ1 that my default cost is going to be 3, what I'm saying is that the cost is in total will be 13. So if I say area 1 default cost of 3 here, we automatically choose the route through HQ2, correct? Again, take a look here. We're automatically picking the path through HQ2 to get out. from the distribution router because the cost this way is 13. What about the cost into, right? So when I come up to gateway 1 and I say, and we actually did it with the show IP route already, what would be a network down there off of, what is that loopback 0 network down there? 192.168.4.4. So 192.168.4.4, whoops, sorry, .4.4, that's what it looks like right now. Let's rerun that command. And what does it look like? So we are still load balancing. Do you see that? Ingress traffic into area 1 is still load balancing over both paths. We do not want that. It's got to be one or the other. So we took care of the egress traffic from area 1. We know right now, because of the default metric change, that it's going out router 2, HQ2. So to influence the ingress traffic, I can't tweak the metric, the default metric again, right? I've already done that. So what I need to do is remember that when OSPF is looking at the cost values, basically what I said was the default metric cost here is going to be 3. So the default is 3 plus the outgoing interface of 10 is 13. Over here on HQ2, the default cost is what it normally is, the default of 1 plus 10 for 11. That's why we're seeing that 110/11 when we look on distribution here and see that that is our number 1 path, where I give it the check mark, right? That's why we're seeing that, because right now, if we could see it, this would be 110/13, because the cost would be 13. So we've taken care of the outbound egress traffic, but from gateway's position, he says if I go this way or if I go this way, I'm seeing the same cost. I can't remember if it was, well, actually, what is it going to be? It's going to be 10 to get out that interface, and then 10 to get out each of these interfaces, and then 1 here. So it's 21 is what he's seeing. So how can we manipulate OSPF so that from the perspective of the gateway router, right, from this gateway router here, that this path looks better than this path? Now, I could change the OSPF cost there, but that doesn't do anything, right? Because it's going to be equal for both. It's going to be here or here. It's one of these two interfaces where we need to make that change, right? Well, we already know that's going out HQ2. We want it to come back in, I want it to come back in HQ2. So let's add to the cost of the Ethernet 01 interface on HQ1. Because again, remember, they're going to be calculating these costs based on the outbound interfaces toward our destination. So if I clear this here, and let's go back to the pin, let's get on HQ1, and let's jump on interface Ethernet 01, interface Ethernet 01, where I'm going to say IP OSPF cost, and what is the difference, right? It's equal now. So if I just simply said the cost is 10, if I make the cost 11, what is that going to do on gateway? So I made it 1 larger than it was. So it was showing 21. Who's going to win out now? Exactly. There is my 192.168.4.4, and we're going to 123.2. So if I trace to the 192.168.4.4, whoops, I'm going to go to 123.2 and then 24.4. If I come down to the distribution router and I try to trace out to the internet, to the 209.165.200. Oh, what was it? It was 225? Yeah, we go to 24.2. So we still go to HQ2. So now we've manipulated things so that ingress traffic and egress traffic is all transiting HQ2. So what if we want to flip it? What if I want everything to go out HQ1? So let's just do the opposite. Let's get on to HQ1, and we're going to remove that statement there. We're going to get on to, and actually HQ1 also has the router OSPF1 do show run section OSPF. And there's that area 1, no area 1, default cost of 3. And again, I could have made that 2, and that would have been enough to push it over the limit. So that's what we'll do, going the opposite direction. So now from gateway, let's take a look again at show IP route, where are we at here? OSPF, and let's say 192.168.4.4. 4.4, and do I have to say, was it 24 or is it 32? Sorry. Is it 32? No. What am I missing here? Show IP route OSPF. Oh. No, that shouldn't even do. I should. Oh, I'm thinking the database. I apologize. So we're going to say show IP route OSPF. Sorry, I was thinking about the database. But here we go. 192.168. So again, we're back to the way we were, right? Ingress traffic coming from the gateway is being load balanced. And then egress traffic, do show IP route OSPF. Egress traffic is, again, because of that default being sent in, is being load balanced. So we're going to do this in the opposite direction. So how would I do that? I want everything to go out HQ1. So the first thing we did was we tweaked the default metric for the outbound. So how would I do that? If I get onto HQ2, and I'm going to get into router, global config from privilege exec, and we're going to say router OSPF1. I'm going to say area 1, default cost, right? And let's make the default's cost just 2. So one more than what the default is. So now when I come down to distribution, there you go. So that takes care of the egress path out of area 0. I simply said that, hey, the cost for the default that HQ2 is sending in is worse by 1 than the cost of the default being sent in by HQ2. And these are the things, and I tell you what, these activities are absolutely phenomenal because they really get you to start to think about, okay, well, what if I do have 2 ABRs that I could ingress and egress from? What am I going to do? How do I handle that? And so this is a great use case because typically this is what you see, is when you have multiple paths, if you're sending into a stub area a default route and you've got 2 ABRs in and out, these are the use cases that you're going to end up dealing with. And this is a very simple way to deal with them. So we've done the default cost for the default route that's being sent in. So the egress is taken care of. So now we know on the ingress, it's just the opposite of what we did. So egress, we're going this way because my cost here now is, well, I shouldn't say plus 2. It's basically the default cost is going to be 2. And so what would it look like if it was showing up? It would be 110.12, right? Coming this way. Coming this way right now, it's 110 is the administrative distance, and the cost is 11. And we saw that, and that's what we see in the routing table right now. So that's getting out, right? Now, what about coming inbound? Well, there's my outbound interface into area 0. There's the outbound interface into area 0 off HQ1. So I simply want to make HQ2 look less attractive than HQ1. The cost of that link is 10. I'm going to make it 11. So then gateway is going to see a cost of 22 coming this way and a cost of 21 going this way. And the reason this is important is if we didn't do this, right now, this is what would happen. The distribution router would send its traffic this way, and we could run into asymmetric routing coming back in that way. Because again, we're load balancing coming in this way, right? So there's a possibility that we could run into have unexpected results. So let's go ahead and on HQ2, jump into interface Ethernet 01, and we're simply going to say IP OSPF cost. Now remember, this isn't an additive command. The cost normally is 10. And how do I know the cost is 10? Remember, do show IP OSPF interface. Ethernet 01 right here, cost is 10. When I say IP OSPF cost, this is not in addition to the 10. Okay, this is replacing the 10. So all I'm going to say is 11. So let's say do show IP OSPF interface, and there you go. If I was to make it 12, that would show 12, but we made it 11, so we see 11, right? So now from gateway to, the gateway's perspective here, whereas before I had two paths, equal cost of 21. Now when I say, get control of the mouse here, now when I say show IP route OSPF, the cost is simply 21 out the best path, which is router 1. So what happens then if I shut down Ethernet 00 there? And let's see if we end up with the expected results. Interface Ethernet 00 shut. Let's come back up to gateway here. And let's run this command again. And we may need to wait. Yeah, I think we're going to have to wait for the dead timer to expire. But what we should see is my path to get to the 192.168.44 now is going to be going through 172.16.123.2 HQ2. And again, we're still hanging on to that show IP OSPF neighbor. We're still hanging on to, 4 seconds to go here. 3, 2, 1. We should see, there we go. All right, so now let's come back with that show IP OSPF route. And I'm still showing going through the 1. There we go. Okay, I was hoping it wasn't going to do what it did before. So there we go. So now we're going to router 2. But what is the problem? Now what do we have? If I go to the distribution router and I say do trace to the 209.165.200.225, what's my problem? Yeah, my egress is going out router 1. So this is what you need to be careful of, because again, we've engineered everything to go the path of router 1, but the link between distribution and router 1 is up. There are no problems, right? So their adjacency is just fine, but this is the result because we go out router 1, but the Ethernet interface on that shared segment between HQ1 and gateway is down. So now we have a problem. We've got no connectivity, right? So be aware of that when performing your traffic engineering, especially when you're coming into and out of areas where you've got more than one ABR or more than one ASBR that you're using. All right, well, this is going to wrap up challenge activity number 6. And these are great activities. They really make you stop and think, especially that last item down there. I love when you get scenarios like this. Make sure that the traffic to and from area 1 flows in both directions over the same ABR, because it really makes you stop and assess, how am I going to do that? How is that going to work? So again, fantastic activity. Thanks for watching, and I will see you guys in a couple of hours.